All right, so this is our review of the AP Computer Science A curriculum. It's broken up over the course of 3 periods, or in the case here, this should be 3 videos. The way I've designed this is I set it up and I did some calculations. So I mentioned this to you guys the other day. Based on the number of topics and subtopics, I kind of broke up the units, the 10 units that way. And then I also broke it up based on the way the AP is weighting this for in terms of how much it's on the exam, compared that data, looked at the differentials, and then kind of designed it and then put units together into 3-unit package or 3 period packages of units. So today we're going to do 3 units from the AP curriculum, and next period we'll do 3 units, and then the last period we'll do 4 units. Okay. All right. So today, period 1, there will be 3 units from the AP curriculum, but we will be doing 17 total topics. So you can see here, Unit 1 has 5 topics, Unit 3 has some topics, and then Unit 4. So that equates to about 3.5 minutes per topic is generally what I'm going to try to shoot for. Okay? So I don't want to talk too long or too short on each topic. And what I want to do, and we'll get into that in a minute, is I want to go over what it specifically says in the AP curriculum. This should be knowledge you have, because if you kind of look at this, this is stuff you learned in the Computer Science 20S course, essentially variables, if statements, and loops, or in Unit 1 of the 30S course, when we first did it in Java in variables, if statements, and loops. So you have been doing this for a while, but what I want to do is make sure that in case you have any questions about any specific language or specifically what the point means in the AP curriculum, that's what I thought you guys would be looking for, is a specific deep dive into the curriculum content. All right, so let's get started with Unit 1, Topic 1, why programming, why Java, okay? And you can see here the 5 subcurricular points that it makes with this. Okay, now 1 sec while I get the pen ready here. All right, so it first talks about calling a system class methods. So the system class is built into Java's core language, okay? And it's from that system class that you can then get into one of its subclasses or one of its sub-libraries, the out section, and then from there you can call methods like print and println or print line. That's what the ln stands for. Okay, and you can see that here on the second point, system.out.print, system.out.println. So what this does is it provides output to the default device of your hardware. And with any standard laptop or desktop computer, that's going to be your monitor. So the system.out.print and println is going to send the stream of output to your monitor. Okay? You can also see the difference between print and println. That's what's covered in point 3. Println also puts the output on the default display or on the monitor. That's what print does, just displays it on there. So if you call it and then you call it again, it will print on the display monitor. But println will print it and then apply a new line character. Right, a break to the new line. And that's what it says there. Move the cursor to a new line, while system.out.print does not do that. This should be pretty simple stuff for you guys, but then I want to cover the next point that's covered here, and then we'll move on to the next one. And that is, excuse me, the idea of a string literal. This might be a term you're not familiar with. I don't use that term very much. It's a pretty formal term. But all that means is something inside of quotes, some words, some characters. Inside of quotes is essentially what you could call a string literal. That's what that means. Okay? So like this could be put inside a system.out.println, right? You could be printing that. You could also be doing something which we'll see in a minute, assigning that to a variable. So you could be assigning a variable, a string literal. Okay? A string literal is enclosed in double quotes. That's all that means, okay? So it's a string of characters that you place within two quotation marks. All right, let's move on to the next second topic. So from Unit 1, variables and data types has 9 subtopics here. So this is now we're going to start digging into the specifics of what variables are, okay? Identify the most appropriate data type. So when we're talking about variables, the type is essentially what it stores, right? So this is what you learned back in the intro computer science course. Basic data types include the integer and the double. Those are both number types, right? So numbers can fall into those two categories. Yes, there are more than just those two types. For example, there's the short and there's the long, but those are just derivations, of the integer and the double. So sort of a little more specific. For example, there's one called the U short, which just means it's a shorter data type than integer. So it can store less value, and it's unsigned. That's what the U means, which means it can only store positive numbers, okay? So that's what data type means. Now we go beyond numbers, right? There's the Boolean variable, the most simple of variables, just the true-false variable, okay? There is, then we get into the character variable, or the char variable. And then even there, we start to get into more advanced stuff, like maybe the string type, but string is a little fancier, so we'll kind of put asterisks beside string. Okay, so a type is a set of values, a set of operations on them. Okay, so that's a weird way that the AP phrases that, right? A type is a set of values, a domain. So what it's talking about there is a lot of these things have sort of limits. That's where I think the word domain comes. So the integer can't be an infinite size. It has a set size, right? And if you needed something larger than what integer could store, you'd have to go to the type long. Also, integer does not allow decimals. That's its range, whereas the double does allow decimals. So that's what they mean by range or of the set of values, right? It's sort of limit to them or a size to them, etc. Data types can be categorized as either primitive or reference. Again, a strange phrasing by the AP. I get the idea that these are what are called primitive data types, sometimes called atomic data types. Primitive data types are those basic data types: integer, doubles, Boolean, character, whereas a string is, I would use the word advanced data type. That isn't working very well, there we go. An advanced data type, but they might use the word reference data type. But all that means is a string is a reference to a class object, but we'll get more into that in the second presentation. The primitive data types in this course define the set of operations for numbers and Boolean values. So again, it's basically saying you don't need to know all of these things, but generally integer, double, and Boolean will work with numbers and true, false, and then potentially character. Declare variables of the correct types. So again, it's saying when you create a variable, make sure it's a type that's appropriate to represent, say, data that's primitive, okay? 3 primitive data types in this course are integer, double, Boolean. So there it is. It doesn't even acknowledge the char as a primitive type, which it is, right? But the AP kind of wants you to focus on integer, double, Boolean. Each variable has memory used to hold a value. You've seen me multiple times draw this out for you guys, where I'd say, okay, a variable, and I would draw like a little box on the screen representing, right, like something like this, int x equals 10, and I would draw a box, say this is x, this is 10, and it's of type integer, right? Like that would be the code you write. This would be what's going on inside the memory of the computer. You've seen this at a simple level at the 20S course and a more advanced level by the 40S course. Okay, the memory associated with a variable of a primitive type holds an actual primitive value. That, again, I think makes pretty clear sense. When okay, so this one is an interesting one though. When it's declared final. Final is the key word used to create a constant, a variable that will not change. Okay, its value cannot be changed once initialized. Now, it doesn't even use the word constant there, but that's what it is. Whereas in other languages like C#, they use the word const. The word final will lock a variable so it cannot be changed. That's what a constant is. All right, let's move on to our third topic under Unit 1, which is expressions and assignment statements. Yes?
I have a question about the constant. Should we be initializing constants just to avoid magic numbers while we code?
Yes, I would say that is a good idea. Let's step back and look at constants again for a second. Okay, so when you create a constant, now depending on where a constant is created, if it's created as a class level property, then you have a few sort of options. But I think just in general for the exam, if you're starting a line of code with final, whatever you're creating, whatever data type you're putting right here, whatever name you're putting here, if you're putting final at the front of a line of code, you should be putting an equal sign and you should be giving it a value right here, right? To me, that would be my advice for just rule of thumb that you should work on. So if you're saying I'm making an int called room and I'm making it 300, because, then I'm going to do that, right? Now, I know I've also taught you guys that constants should be written in all capital letters. I'm not sure if the AP actually cares about that or not, but I also don't want you to break your style. So do that, right? Write them in the all caps style. Use the underscore if necessary, but I don't know if that would cost you a point on the exam or not, right? So maybe you make a final double called pi, P capital I, and you make it 3.14. But the point was, yes, I think you should initialize your variables. All right, let's move on to these subpoints. Use arithmetic expressions in program code. So obviously, having done a bunch of practice questions, you can see the AP likes to put little math questions at you in the form of code. A literal is the source code representation of a fixed value. So that's a weird way of putting it. That's sort of a mathematical term. So if I do something like this, int x equals 3 plus 7 as a line of code, technically 3 and 7 are literal constants. They're not changing, they're not variables, but we don't tend to phrase them that way. We just essentially call them numbers, right? The number 3 and the number 7. But those are essentially what it means when it's talking about like literal values, right? They're literally 3, literally 7, they're not changing, right? Arithmetic expressions of type int and double. So we could also do this in a mathematical way. With doubles, and those would be literal constants, right? 4.2, 3.7, they're literally the numbers. Again, we wouldn't necessarily use that vocabulary. Arithmetic operators or operations consist of the addition, the subtraction, the multiplication, don't forget that's a star on your code, the division, don't forget that's the slash symbol, and the one that will probably show up most in exams because it's the tricky one is that one, the modulus division. So don't forget about that one. The modulus division means you'll divide the numbers, but what you're looking for there is the remainder of the division, not the quotient, right? You're looking for the remainder. So watch out for that one would be my advice for that point, number 4. All right, an arithmetic expression that uses 2 int values will evaluate to an int value. That you can see right there. So that's a good example of point number 5. When you're adding ints, you get an int, okay? 3 and 7 are literal constants, but the computer will interpret those as integer values. But also, if you've created a bunch of integers, int x, int y, int z, and then you add those together, you should expect the result to be an integer. The computer is very literal in what it does. If you're adding integers, the result is an integer. Now, the next point is, an arithmetic operation that uses a double value will evaluate to a double value. So it's the same with double. If you're doing math with doubles, expect the answer to be doubles. Even if this was 4.0 and 3.0, and I'm subtracting them, the answer would be 1.0, which has no decimal portion to it, but don't assume that's an integer. 4.0 minus 3.0 will give you the answer 1, which is an integer, If you're working with doubles, expect the result to be a double. This is pretty simple stuff if you think about it, but this is often sometimes how they might trick you on a question, is they might have int x equals and then have that as one of the potential outputs. Okay, operators can be used to construct compound expressions. So that's just, again, basic, like this curriculum points a lot about how code and math kind of cooperate with each other, which means even though you're writing code, code still follows the rules of math that you might have used a P for, especially if you're in the French track, right? B-E-D-M-A-S, which is, say it out loud with me, brackets, exponents, right? Division, multiplication, addition, and subtraction. Although it is a little misleading, because division and multiplication and addition and subtraction are said to be of the same order. So it's not like it would do addition before it would do subtraction. They're of the same order. Same with division and multiplication. If you have an expression like this, 3 times 7 divided by 4 plus 2 minus 1, okay? It's not going to necessarily do this addition before the subtraction, just because A comes before S. Those are of the same order. Then you got to remember, once BEDMAS is in place, the code will always evaluate, okay, from left to right. Right? So if you have things of the same order, it's going to go left to right. Okay? So these two are of the same order, multiplication and division, but it would go left, do this first, and then that next, because that's left to right. Unless you have exponents or unless you have brackets overriding the precedence order, right? Or the order of operations is what it's generally called. Again, I'm not sure what you guys called it in your math class. Computer scientists tend to use the word precedence a lot, just sort of implies that some things come before others. Okay. Yes? Where does casting fall? Well, let's hope it comes up. Let's see if it comes up, and if it doesn't, then we'll address it after that. Okay. During evaluation, operands are associated with the operators according to the operator precedence, see there it is that word, to determine how good they are grouped. So that's essentially a very strange phrase that describes what I just told you, that there's an order of operations taking place. An attempt to divide an integer by 0 will result in an arithmetic exception to occur. So in math, when you try to divide by 0, your math teacher says, well, you can't do that. In code, if you try to divide by 0, so you say write a line, that line would generate an error when run, right? Because it would generate a specific error, and don't forget the word error and the word exception in code mean the same thing. They're synonyms, right? So if you're saying it's an error, and I'm saying it's an exception, which you often see in the sort of code language, it's the same thing. And that is an arithmetic error, or an arithmetic exception. The math is the error, okay? Evaluate what is stored in a variable as a result of an expression with an assignment statement. So that's some weird language again, but it is language I have sent to you guys before. This is an assignment statement. The word assignment in this context means you are assigning this variable a value, okay? Sometimes this symbol is called the assignment operator because its job is to assign a value to a variable. That single equal sign means assign this 5 to the variable x, okay? So that's when you see that in the curriculum, that's what it means. This is an assignment statement. Sometimes it's called a declaration statement because you're declaring this variable into existence, but at the same time you're assigning it a value. If I just did a line of code that went int x, that's just a declaration. There is no assignment taking place, which is, I don't think, good code. You should always create an assignment there with it, okay? All right, point 11, the assignment operator. Look at that. It used my words, right? Allows a program to initialize or change the value stored in a variable. Okay, so let's focus on the word initialize. If you see that come up in your exam, what does that mean? That means, what's the root word of the word initialize? Initial. What does initial mean? The beginning or the first, right? So what it's saying is, when I initialize this variable, it says I'm creating it and giving it a starting value. That's really what that means. To initialize something means to create it and give it a value right from the start. But I can change it. I can write a line of code like right under this. So, okay, here it's been initialized. Oops. And now I change it. X equals 7. So here it is initialize. It's a little harder. And here it is changed. Sometimes they'll use the word reassigned, right? So don't get, if you see those words, they don't have a complex meaning. It's just that I think whoever wrote the AP curriculum liked to use really fancy verbiage in the way they write up curriculum points, but don't let that throw you off from the question itself. Okay, point 12, during execution, expressions are evaluated to produce a single value. Okay, that just means a variable isn't going to be two values at once, right? It's going to do one value. And then 13, the value of an expression has a type based on the evaluation of the expression. So this is where, and I'm glad Cam you brought that up, like there could be a casting kind of taking place. And I have noticed that the AP likes to sometimes do these types of questions as well. So they might do something like this. And they'd say something like, what type would that be? What data type would be here appropriate? And you see an integer, or what could be interpreted as an integer here. You see another integer here, and you see a double. Okay? So what would your guess be? What would be the data type that could be generated from this arithmetic operation? Double. Yeah. If you're seeing decimals in play, there's a good chance that it could be certainly decimals. Now, if this was just 4, okay, then you could assume that maybe that's an integer that's being generated there because there's no decimal value there, right? However, how would you interpret that? Because what's 5 divided by 2? Well, it's going to be 2.5, right? And then I'm adding 2.5 to 4. So is that a double? Okay, why? Why does integer operations not generate necessarily result? What would this result in instead of 2.5? 2. And what is that called when it just throws away the 0.5 part? Truncated. Good. Okay, I don't see that on here, but you guys have the vocabulary down really well, okay? Okay, so that's curriculum point 3. Let's move on to curriculum point 4. Compound assignment operators. Again, very complex wording, but it should be stuff you guys know. Excuse me. I take a sip of my coffee here, kids. Evaluate what is stored in a variable as a result of an expression with an assignment statement. That's again what we were just doing, right? Int x equals, and then it does a bunch of math here. It does some BEDMAS here for you to look at. So there might be brackets going on there, okay? There might be, as Cam pointed out, possibly some casting. I don't know, maybe. That could be going on in there. So let's write something like that. What if x equaled now, I don't think it would make you do something like that mentally. Whoops, and I think I dropped a bracket. So. Okay, but it could be a multiple choice question where they have this, something like this. They'd maybe make it so you could do it mentally, right? So not 3.2 plus times 1.7, because I wouldn't want to do that in my head. I'd want to do it with a calculator. But let's say this, results in a decimal value. Adding it to what looks like an integer value. And then over here, one of the potential answers is a double answer. But here you can see that casting is taking place, right? So maybe you gotta watch for that, right? So evaluate what is stored in a variable as a result of an expression with a assignment statement. So I'm assigning it an expression, a math expression, okay? Compound operations, like the plus equals, the minus equals, the times equals, and the divide equals, and even the mod equals, can be used in place. So now they're gonna get really fancy on you. And again, I'm not sure how many of these types of questions you guys have encountered in your practice this course, but I'm sure they have come up, where you'd get something like this. It'd be like, what's X at the end, right? Now, again, I didn't pre-plan this math, so I'm not sure how it would go. But you gotta at least recognize that we start off with the assignment of the value 5, right? So X starts off as 5. Then we add 7 to it, right? So now it's 12. And then we divide it by 2, so now it's 6. And now we multiply it by 10, and now it's 60. And then we, what's this last operation gonna do? Mod it by 3, which means 60 would be divided by 3. 60 divided by 3 is 2, right? Remainder, 0. Okay? 60, it's 20 actually, yeah, sorry, thank you. All right, let's try to do this quickly. He's checking my math on me right now. But yeah, then it would be 0, right, at the end, right? But like I just made up those numbers, so I'm glad they at least kind of worked out. But that would be what it's meaning in that statement. And then both the increment and decrement operators are used to add 1 or subtract 1. That's pretty basic. I hope you guys know that. The plus and the minus. Now it does mention here the value of a variable or an array. So they're mentioning here that the plus and the minus could come up when working with arrays. All right. Topic 5. We got to pick up the pace here. I think I'm a little over some of the times on this. Evaluate arithmetic expression using casting. Thank you, Cam, for bringing this up. So we've already talked about that. So this is an example of casting, right? I'm casting what appears as a literal double into an integer. Casting will, and you guys already said it, truncate. It will not round off, which means it just throws the decimal portion away, right? That's the way truncation works. That's the way casting works, okay? However, and I'm not sure if they'll give you a question like this, but, wow. This is also a cast that can take place. Casting the character literal A into an integer. Can anyone figure out how that would work? How would the letter A be cast into an integer? How? The ASCII table, right. So in the back of the room over there is a copy of that ASCII table. Now, of course, they're not going to have you memorize that for exam question. I don't have it memorized. It's 65, but I don't have it memorized, right? I don't have the ASCII table memorized, but there it is. All right. Casting integer and double can create a temporary value converted to a different data type, like we said. Casting a double to an int causes the digits of the right of the decimal point to be truncated. So there it is, the same value, the same vocabulary appearing in the curriculum, right there. Some code causes int values to be automatically cast into double values. So that's a weird way to put it, but let's sort of give an example of what that would mean. This is valid. This is valid code. Now, it's going to interpret these two things perhaps as literal integers. So the result, 6, could be also interpreted as a literal integer. However, it wants to assign that 6 to a double. So what this point means, point number 4, is that it can do that, because that's not something that would require even a truncation or anything complicated, it can easily turn 6 into 6.0, right? That's not going to take any particular work on the computer's part, but it's not true the other way. And a double will not automatically be cast into an integer. You have to be specific about it. Now, you can be specific about it. You could have done this. And that would also work, right? It's just that with doubles, you can't assume that. However, with integers, you can't just do that. It won't do that unless you cast it. Then it would do it, right? It would evaluate this as a literal double, evaluate a literal double result, and then truncate the result to cast it as an integer, to assign it to the value. Okay, integer values in Java represented by the values type int are stored in a finite amount of memory, 4 bytes of memory. Just as a subpoint, how many bits are in a byte? A bit is a 1 or a 0. The word bit stands for binary digit. That's where the word comes from. So it's a 1 or a 0. A byte, anyone remember, is a set number of bits. Anyone remember how many? 8. 8 bits. Okay? There's actually also a word for 4 bits. This was a joke, not a joke, but this is a real stat I said in the 20S and again in the 30S course. Does anyone remember? This is a fun little point here in the middle of this presentation. It's called a nibble. 4 bits is called a nibble. All right. Now it says, therefore, an int value must be in the range integer.minValue to integer.maxValue. You do not have to have those memorized for the test. Just know there is a limit. For integer, it's about 2 billion is the limit. And then it goes to the minimum, which is negative 2 billion. Okay? If an expression would evaluate to an int value outside the range, an integer overflow occurs. This will result in an incorrect value. This is an interesting point. When you keep increasing an integer, it won't crash when it exceeds the value 2 billion. It's not exactly 2 billion, it's 2 billion and something, but let's just go with 2 billion. So if you say we're using a loop and say squaring an integer and it kept growing and growing and growing, it won't actually crash. What happens is what's called an overflow error. So the integer value overflows and it kind of resets back to the beginning. You might remember that when we did the recursion unit in the 40S course. We were using factorials and we kept growing them until we got some weird answers. Do you remember that? And some of them were negative numbers. That's because you overflowed integer, and although it's trying to do an evaluation for you, it's not representing it properly. It's representing it incorrectly. Okay? All right, let's move on to curriculum point 6, Boolean expressions. So I know it's pretty obvious, but whenever you see this word in your AP exam, that's just talking about true or false. Now that could mean you're talking about the variable Boolean, because you know you can create a Boolean variable. But it could also mean that you're talking about a condition. A condition for like an if statement or a loop statement. This is why loops are actually also called conditional statements. They rely on a true-false condition. So whenever you hear the word Boolean expression, remember the word expression means you're creating a bit of like mathematical comparison or mathematical assignment. So you're creating some condition that's going to evaluate to true or false. So more simply put, like if 5 equals 5, that's a condition. Is that condition true or false, right? That's what's happening there. Primitive values and reference values can be compared using the double equal sign and the not equal sign. Okay? So what that means is, if we go back, integer can be used with these two. Double can be used with those two. char can be used with those two, and Boolean can be used with these two comparison operators. Is that what it said? Well, it calls them relational operators, which is fine. That's a good way of putting it. You're relating one thing related to another thing. And it's going to evaluate to true or false. What you can't use these two for are non-primitive types, what I would call class level types. And the first one you encounter that you can't use those with is string, because strings aren't primitive data types. So with strings, you can't use a double equal sign and a not equal sign. So watch for that. They could try to trick you with that one, okay? Now you can also then go into the mathematical comparison operators or relational operators of less than, greater than, less than or equal to, and greater than or equal to. Those mathematical comparison operators allow you to work with numbers in a more accurate way. Now it gets a little dicey when dealing with Booleans. Like, have you ever thought of that? Like, is one Boolean less than another Boolean? Is one Boolean greater than another Boolean? I don't know if they'd throw that type of question at you, but for study's sake, let's take a look at that right now. Let's see if we can create something like that. And while I'm typing this, somebody open up an actual code window somewhere. I want to actually test this. Sorry. Okay. Would it produce one of those outputs? Is A greater than B, or is A less than B? Before any of you actually put it in, what's your prediction? Nobody's willing to make the prediction. You got a 50-50 shot. It's going to produce one. It may produce neither. I guess it's a 1 in 3 shot. Maybe they're considered equal, and therefore A is not greater than or less than. So who did it? What's the result? Is A greater than B, or is A less than B? Still working on it. We gotta fit our time, 3.5 minutes, guys. We gotta go. Okay, so while you're evaluating it, let me just move on to the next one. An expression using a relational operators evaluates a Boolean value. I already said that, so we got that one down. But which is it? Did anyone actually run it? Nobody ran it.
It's not letting me. It's not compiling.
It's not compiling.
It's not compiling.
Why? What is it saying?
That operator. It just doesn't allow you.
It doesn't allow it, yeah. But you know what might be interesting? Instead of these two, take these out and just do output A and B cast as an integer. So if you cast A into an integer, what would it be? If you cast a Boolean, will that be allowed by our compiler? Will A and B allowed to be cast into integers? Right? Because then if they're numbers, we could maybe do something like consider it an if statement.
Again, inconvertible.
Inconvertible, yeah. Okay. So generally, if I was to guess, because languages like Java may not interpret it this way, but other languages go more simply. True is generally considered a 1, and false is generally considered a 0, right? That's generally how it goes. So A is greater than B in this case, right? But Java has protections in its core language that kind of prevents you from worrying about that. Anyways, let's not worry about it. Let's move on. All right, topic 7. Holy moly, I got to pick up the pace. If statements and controlling the flow. So this is, again, pretty simple stuff for you guys, representing branching. Branching means if statements, right? You branch one way, you make a decision to go this way or a decision to go that way. Logical process using conditional statements. That's the word I use with you guys, a conditional statement. or an if statement, that essentially means the same, or a branching statement. So if you see that appearing in an exam question, those things all mean the same thing. It's an if statement, it's a conditional statement, it's a branching statement. They interrupt the sequence. I don't know if they interrupt it so much as they decide which part. Should I do A or should I do B? I won't do both. I have to decide right here using my code if I should do this, else if I should, for example, do that. If statements affect the flow, that makes sense. It flows this way and then comes back to here, right? So am I flowing this way or am I flowing that way? Okay? By executing different statements based on the value, and these things then evaluate to true or false based on that condition, right? That's the way you write the if statement. If true, do this, else do that. Now here it gets some, what it describes as common language. Yeah, I wouldn't say it is, but whoever wrote the AP curriculum thinks it is. A one-way selection, an if statement. Until I taught AP, I'd never even heard that in my computer science career. A one-way selection is written where there is a set of statements to execute under a certain condition. In this case, the body is executed only when the Boolean condition is true. What they mean by that is it's just a basic if statement with no else. If this is true, do it, otherwise don't. I think that's what they mean by a one-way if statement. Okay, moving on to the next point, where they bring an else in curriculum point here, it says, represent branching logical process using conditional statements. Same point. A two-way selection is when there are two sets of statements. So what I mean is, if something's true, right, we do this one thing. Okay? If it's true. If it's false, we don't do that one thing. This would be considered a one-way conditional statement. It's checking one thing. Then we could write an if statement with an else. Okay? And now you know it'll do this one thing if it's true, and this thing if it's false. This would be considered a two-way in the language of the AP, conditional statement. One way checks one thing, two-way essentially checks two things. Now, could that be incorporated into what you know as the else if statement? I don't think so. I think this is what it's talking about, okay? With the if and the else. Okay, so let's move forward. Now it moves to else if as the next point. Represent branching, a multi-way. So if this is a one-way if statement, and an if with an else is a two-way if statement or conditional statement, then an if and an else if, and I can add more else ifs, and I can add else. This they're calling a multi-way conditional statement. Okay? This means it's going to make a decision amongst more than two things. Could be 3, could be 3 million. Okay? So let's go back. Oops. This decides one thing. Decides one thing. It's a one-way conditional statement. This decides two things. True or false. So only if it's true or false. And this decides more than two things. Maybe many, many things, which is why it's called multi-way. Okay? And that's again what I think this is all saying, using an if, else, if statements. Selection of code is executed based on the condition that first evaluates to true. You have a lot of experience with these types of code branching, so don't overthink those questions. It means what you think it means. All right, topic 10. We're closing in now. All right. Represent branching using nested conditional statements. So you guys know what that means, okay? Nesting means you're placing a conditional statement inside of another conditional statement. Well, let's get a little more, before I read the curriculum points, let's get a little more specific about some vocabulary here. Okay? And I'm going to change colors here if I can. Yep. This thing is called the block of that conditional statement, right? It's the block that the conditional statement controls. this is the block of that conditional statement. So we're placing this conditional statement inside the block of that conditional statement. That's what nesting means. You're nesting the logic inside of the other logic. Okay. I think that should be clear for you guys. Nested if statements consist of if statements within if statements. It's literally saying that. Evaluate compound Boolean expressions in program code. I'm not sure why that's, well, I guess that's what that could mean, and I think it relates to the very next point, is when you write that condition right here, if it's true or false, this could be just a simple expression, like if x equals 5, that's a simple expression, or it could be a compound expression, which means I could use this expression and then another expression in here. So the first expression and then another expression, compounding the logic. But in order to join that compounded logic, I need to use the logical operators. And those are not, and or. Okay? So I could slip one of those in here, like the or statement. So I could say, if this is true or this is true. I could slip the and statement, if this is true and this is true. And I can slip the not in there, if this is true and this is not true, right? By using the not symbol, right? So the not symbol is kind of optional because you could just switch your if statement to say things like true, false, etc. But it's generally used, okay, within the Boolean expression. Okay, I don't know why they use the word value there. I think that's incorrect. It represents the order these operations will be evaluated. Okay, an expression involving logical operators, a value, so the whole thing still evaluates to true or false. Okay, an expression, when the result of the logical expression and an or can be determined by evaluating only the first Boolean operator, then the second is not evaluated. So that's a weird one, but a good one. I think that's a good point. Let me see if I can give you an example of what it's talking about with that one. Actually. Okay, so say this is the code you have. X is 5, Y is 7.3, integer and a double. It comes to a compound if statement. If X is greater than 0, well, is that true? Yeah, X is greater than 0. Now it encounters the or statement. Does the rest of this expression matter? No, because with or, if any of them are true, then the whole thing is true. So at this point, it can stop evaluating. It doesn't need to go any further. And again, I could have ors, like 7 ors going on here, not just one. But I encounter something that's true with an or. Now I switch the symbol. Now I do have to keep going to check this. Okay? But let's make something else happen here. Is 5 less than 0? No. That's false. Do I need to keep checking? No. Because with and, they all have to be true. And since something's false, it's already fallen apart at this point. We don't need to go any further. This is done. And that's what that point means. I've seen them do those types of questions where they give you something complex, but you could kind of evaluate it quickly. If you realize the first thing is wrong, you don't necessarily need to go to the rest of it. All right. Closing in on the end. Point 11. Equivalent Boolean expressions. Compare and contrast equivalent Boolean expressions. So they use some very interesting language here that appears, I think, for the only time within the curriculum. They mention this, De Morgan's Law, and this, the truth table. Now, I have covered that with you guys, but there isn't a big curricular desire to do this. I don't know exactly how deep they want to go on this, but let's just jump over and literally ask a much more concise thing, like Google itself. What is De Morgan's law? Okay, so it's technically a law of mathematics, specifically Boolean algebraic mathematics, but that Boolean algebraic mathematics specifically relates to computer science, because computer science lives in a Boolean world. So it's basically what's called propositional logic. This is a math expression, which again, you may not have encountered in your math classes, that defines a relationship between and or, okay? And essentially says the state of negation of an and operation is equivalent to or. What it's saying is, if you say not this and this, if x, let's see if I can write that out. Hang on. I'm gonna try, guys. I was worried about this one the most today with you guys. Okay. Okay, so let's look at that. Okay. So we know this is true. We know this is true. Right? 5 equals 5, 2 equals 2. We know that and only works when they're both true. So it's looking pretty good. But then that symbol throws things off a little bit. Not this means that this true has now switched to false. It's now false and true. So with and, this would now be false, right? But what it's saying is, in theory, this is the same as or, right? It's essentially saying this will never be true, but if I change this to or, got rid of that, now it's true, right? Or. So it's a weird way of putting it. So let's go back again. I'm not sure if I'm explaining this correctly. This is a deeper kind of mathematical thing you can do in Boolean algebra, but it's essentially saying the state of the negation of and. So if you negate and, make and a not, okay, which by the way is usually expressed as NAND, it's equivalent to or, and the negation of or flips to and. This is related to something I've said to you guys before in computer science and math in general, is that in math and computer science, every mathematical operation has a dual operation. Whoa. Okay, so it's sort of like the anti-hero, right? So you have like the Flash, and you have the reverse Flash, right? So here we go. The dual operation of addition is subtraction. The dual operation of multiplication is division, right? So what it's saying essentially is the dual of positive is negative, okay? And this is a two-way street, right? You can go back and forth. 0 and 1 are duals of each other, right? They essentially flip each other. And what it's saying is or and essentially flip each other. Or and are that. That's kind of what it's applying there. That based on sort of complex things you could build, you could kind of flip the or and around if they're making things not true, okay? So it's a really weird way of putting it in the curriculum. I don't think we should focus too much on that. You guys have, if you've seen an AP question that specifically mentions either De Morgan's law or truth tables, let me know, and then we can maybe focus a little more on that. But we got a time limit here to wrap up the last couple. Comparing objects. So the key word there is object. We're not talking about primitives anymore. No. So integer, double, Boolean, and char are out. That's not what we're talking about. We're talking of things of level object, and object means they are class type. And the first one you encounter is the string class. Wrote it fancy. String class. So it says compare objects references in code. Two objects are considered aliases when they both reference the same object. This is a weird way of putting what I showed you guys in the 40S course. Something like this, string x equals a, string y equals x. They both reference the same memory location, is the way I put it in the 40S course. What it means here is they're considered, the word is aliases. That's a word, I don't use that one very often, but I have heard it. Aliases, two variable names reference the same data memory location. Those two names are considered aliases, okay? Object reference values can be compared using to identify aliases. So it's saying here, you can use these two symbols, but they won't compare the contents, they compare the memory addresses. So if you said, if x equals y, you'd get true, because x and y both reference the same value. But if I had a different string, z equals the letter a. All right, guys. I will finish the video. I know you guys won't be here for it, but I will finish it, and I'll show it to you guys quickly tomorrow. Okay, and so now let's take a look at this last point. Here, often classes have their own equals method. We know this. We've seen this in a string class before. You would say z dot equals, and then you'd check it with x. We've seen that before in a string class, and you've also seen that before in our own custom classes where we wrote our own equals method. All right, let's move on to those last few curricular points. Point 13. This is about while loops, okay? So you guys should know a lot about while loops. While, or the word loop, also matches up with the word iterative. So iterative means loop, okay? So you can represent looping things with the while loop. Changes the flow of control, that's just like the if statement. Repeating a set of statements 0 or more times until the condition's met. So you know that with a while loop. A while loop is known as a non-deterministic or an event control loop. So while something's true, it keeps looping, right? It's not necessarily built on a count. In loops, the Boolean expression, that's right there, the Boolean expression, as you can see there, is evaluated before each iteration of the loop body. So it goes back and checks it, and then it goes back and checks it, etc., etc. A loop is an infinite loop when it never becomes false, or in other words, it's always true. If it evaluates to false initially, so at the start, then this will never run, right? So that just like an if statement. For algorithms in the context of a particular specification does not require the use of traversals. Identify standard algorithms, modify standard algorithms, and develop an algorithm. This is a weird curriculum point. It basically just means be familiar with using loops in the context of the problem. So if it's a problem about arrays, be used to loops with that type of problem and be ready to not only identify the code that uses the loop, but write code using a loop. And then points 8 and 9, there are standard algorithms that, so these would be examples of things you would do with loops. Identify if an integer is or is not evenly divisible by another integer. So that would be a simple like, right, where you're modding it by 2. If it mods 2, then it's an evenly divisible integer or not evenly divisible. Identify the individual digits in an integer. So an algorithm that can do that is to loop through a string and pull out each digit, right? So if you have a number like 17, turn it into a string, use a string function to pull out a 1 or a 7. Another way you could do that without converting it to a string would be divide it and mod it by a certain value. So for example, 175 divided by 100 gives you 1, remainder 75, okay? So in other words, the answer to the division is 1, the answer to the modulus is 75. Then you can do the same thing with 75. Divided by 10, you're going to get 7, remainder 5, or 5 to the mod, 7, and 1 allows you to pull out all the individual digits of a number using modulus division, right? But another way to do it would obviously be with a string. All right. And then there are standard algorithms to determine the minimum or maximum value, compute a sum, compute an average, compute a mode. This is just your programming practice where you would say loop through a set of numbers and then add to the sum equals sum plus the number. And then at the end of the loop, you can calculate the average by taking the sum and dividing it by the count. And then in here, you maybe increase the count each time through the loop. Something like that would be for average, okay? And then sum, you can see that's already taken care of. And then minimum and maximum is you'd be looping through, say, a set of values. And if your new maximum value is greater than the current number I'm at, this would be maybe in the context of an array, then that's the new maximum, right? The new maximum equals that number that I just found as I loop through the numbers. This is hard to really identify because it's such a general description of what you need to use loops for. This is where your experience using different types of AP question sets will really kind of apply there. So it's a very general way of saying they're going to be putting a whole bunch of looping type questions in what you're going to be answering. Okay? The same thing applies to for loops. So just like with while loops, the for loop, okay, the for loop, which is a deterministic loop, or a count-based loop, okay, used extensively with things like arrays, uses a starting value, uses an ending value, and uses a change value, separated by semicolons, okay? You've seen this before. As it states here in point 2, there are 3 parts, there they are, to the for loop. The initialization, so I'm initializing it, we're starting it at a value. The Boolean expression, that's this here, the expression to determine whether or not it goes again, and the increment value, which is this, it changes or it increments. That actually is inaccurate in the AP curriculum. You could have a for loop that decrements, which means it counts down, okay? Oh, I guess you should have kept reading, that's what it says right there. So the AP curriculum does identify that as increment or decrement. In a for loop, the initialization statement is only executed once, which makes sense. When you initialize, this is the starting value, that's only done once, okay? The expression, the Boolean expression, is checked each time through the loop, okay? The first Boolean expression, the variable being initialized, is referred to as the loop control variable. So that's usually I with a lot of loop variables, but it could be anything essentially, but that's the variable that's using to control the looping, okay? In each iteration of a for loop, the increment is executed after the entire body is executed. Before the expression, you know that. A for loop can be written as an equivalent while loop and vice versa. A one-off error is a common situation with not only arrays, but with for loops as well. So that's something to consider there. All right, let's head to the finish line. Iteration in general, looping in general. Here again, hard to really identify what the AP curriculum is basically saying, but it's saying that you need to use loops, otherwise known as iteration, specifically with strings. So it's saying expect that you would be looping to like go through all the characters in a string. And so looping with strings, and that there are common algorithms for this, right? Find a substring that has a particular property. Determine the number of substrings that meet a certain criteria. Create a new string with characters reversed. So that would be types of questions you'd want to practice, and that's why the curriculum outlines it. All right, heading into the final 2. Iteration, nested iteration. So we've already talked about nested, which is when you put one control structure, whether it be an if statement or another, inside of the block of another control structure. So you have a control structure like a loop with a block, another loop inside of it. So like a while loop with a for loop inside of it, or vice versa. You might have another conditional statement inside of that, etc. Right? When a loop is nested inside another loop, The inner loop must complete all its iterations before the outer loop. So here you can see, like if I had a for loop, this is common in matrices. This for loop goes through the entire scenario over and over and over again until it's done, before it comes back and goes to the next iteration of the outer for loop, which then restarts the inner for loop all over again, okay? And then, in our final piece here, which has gone after the bell when you guys have left, in topic 17, again, a strange way to put it, the informal code analysis, the compute statement executes counts, an informal runtime comparison of iterative statements. A statement execution count indicates the number of times the statement is executed by the program. This is essentially just saying, like, you may get questions where they don't necessarily lay out perfect code, but they essentially lay out how a loop would look, and you need to informally analyze that. And that, kids, is the end of our first review period.